Well, let me introduce myself. My name is Gifre. I'm a senior researcher here at CTTC. Besides, I'm also the chair of the technical steering committee of ETSI TeraFlowSDN open source group. And well, here today, I will present the plans that we have for integrating open source MANO with TeraFlow. And well, also before that, I will be introducing the contributions we did from the TeraFlowSDN open source group to open source MANO. And well, let's get started. So first of all, a brief agenda for today's talk. I will first introduce the TeraFlowSDN open source group for those of you that are not aware of what is TFS. Next, I will be presenting a brief summary of the contributions we did. Next, some experimental demonstrations that we carried out combining open source MANO and TeraFlow. And finally, I will present preliminary proposal of this open source MANO and TFS long-term testbed. Well, let's start with what is TeraFlowSDN. As I was mentioning, TeraFlowSDN it's an open source group at ETSI, but it started as an European research project where we started to define the architecture of a novel SDN controller. A common question that we are asked about when we introduce TeraFlow is, do we really need another SDN controller? Alert of spoiler, yes. The answer is yes. The point is that we have many SDN controllers around nowadays. The problem with them, or the issue, is that they are not designed for what we need for 5G, 6G, and beyond. Also, the other problem is that some of them are kind of deaf. I mean, they are receiving very few contributions. And if we agree that we need a novel SDN controller for 5G, 6G, and beyond, and the current ones are not receiving contributions, we have a problem. We have a gap. That's where TeraFlowSDN fits in. What is TeraFlow then? TeraFlowSDN is, as I said, cloud-native, microservice-based SDN controller. The reason for that is because we got huge knowledge last years on many lessons learned on how web-scale applications should be designed. Also, we have many information, a lot of knowledge on how SDN controllers needs to be designed, or which are the requirements, and also what we can do is combine both of them. That the result is TeraFlow. It's this cloud-native SDN controller that is designed taking into account this scalability, flexibility, extensibility principles. Then, it's hosted at ETSI right now. The idea is that we want to make it last longer than an European research project. For that, what we need to do is to open source it. At ETSI as an open source group, we can do that. Essentially, same principle for open source MANO. I already told that it's microservice-based. This enables us to replicate the different parts of, replicate and scale different parts of the SDN controller, and that brings a lot of flexibility. Also, this can serve as a toolbox for other ETSI ISG and OSGs to play with, to interact with, among others, for instance, open source MANO, and that's more or less the topic that we will be discussing later. We are targeting to support many use cases on automation. In particular, for instance, we are focused on the telecom infra project master requirements. This is a set of requirements that are collected by network operators. And, well, this is a product at the end for network operators at the beginning. So what we need to do is to listen what they need and try to fill the requirements they ask they need. That's part of the game. Then also the idea is to bring some sorry, forgot the word. Well, bring some alignment with the SDO in order to provide an architecture. And at the end, what we are targeting is a reference architecture, so that everybody willing to use or an SDN controller have a framework to play with. And and everything as open source. In this case, we are following Apache 2 license, so everybody can use it without problems. The community behind the TeraFlowSDN, it's growing. It's growing. Last participant, in this case, it's Explore Research, joined I guess it was a couple of weeks ago. So we are growing. That's good, because if we increase the critical mass, that means we'll have more chances to keep this project on. This is the architecture. Briefly, I will not go through all the components because it could take a lot of time. The only thing that I want to explain here, mainly, needs to be recorded. Maybe I can activate the laser pointer. Some points that I want to raise is that many of the components in TeraFlow are based on plugins. So the idea, for instance, in the SBI, the source-bound interface, is that it's based on plugins. That means whenever you have a new kind of network device you need to manage, maybe new protocol, new data model, whatever, you come here, you implement the specific driver, and that's it. Then you can manage a new kind of network device. Same happens with a service. If some new kind of service arises, then you can just implement the specifics for that service, and we are ready to go. The same for the MBI, the northbound interface. Many models, many standards are arising and appearing day after day. It's important to have an NBI that is based on plugins also. We are also supporting plugins here. And well, we have many other components. I will skip the description just for the sake of time, but if at some point you have questions, you can ask me, maybe later. Important point. Well, I was briefly discussing that. Maybe I went a bit fast before, but here it's essentially what I was mentioning before. The northbound interface is based on plugins. Right now we are supporting the IETF layer 2 VPN. We are also supporting the IETF transport network slices data models. On the SBI, we are supporting significant number of drivers, in particular OpenConfig-based OpenConfig netconf for packet routers. We also support transport API from ONF for open-line systems. The IETF network topology for microwave links, in particular through, to control these microwave links through intermediate controllers. Then we also support the Infinite XR optical transceivers. That means we can manage point-to-multipoint connectivity services. And finally, we also have support for P4. That means we can manage white boxes, which is very important, and it's one of the topics that it's quite demanded by the community right now. In case you are interested, you have here the link to the TFS website. There you have all the pointers that you might need to join Slack, to get access to the code repository, to get in touch of the next events that are happening. And in particular, you have here which are the next planned events. The first one, it's just next week in Madrid. It's co-located with the NetSoft conference. And over there, we will be 2 days hacking TFS. This Hackfest will be organized as a set of challenges where some teams will try to fulfill or to complete 4 challenges. The challenges, in brief, are to integrate TFS with a network emulation software. I will present it briefly in a couple of slides. then onboarding the devices in TeraFlow, setting up some new connectivity services, and finally monitoring these services. That's the plan. After that, we are having one entire week here at CTTC, where we will be addressing many TeraFlow points. In particular, we will have the mini meetings. In particular, we will have a plenary, we will have a hackfest, and we will have also an ecosystem day. So there is a good opportunity in case somebody is planning to use the TeraFlow to come and present their ideas, their current work, their plans, and so on. And well, the good point of TeraFlow is that it enables to build an ecosystem. I mean, bridge the research with the ecosystem. That way, for instance, from this 5G PPP project, the TeraFlow 1, we created ETSI, and that can be used to feed 6G SNS. In particular, we have many projects, many research projects that are interested or manifested interest in contributing or using TeraFlow in a way or another. That's good. As I said, it will make the community to grow. You have here a number of them, including some ones quite related to the optical layer. Others, for instance, FlexScale, Season. Others are flagship projects like HexaX. For instance, Acros, it's related to service management. So that's good. We have quite variety of projects with interest. After this introduction, let me continue with the next section about the contributions that we did. Well, I will not describe all of them. It will take a lot of time. The only two ones that I will describe in just one sentence are the first two ones, the ones highlighted in green, because are the actual features. The rest are mainly bug fixes that we had to address at some point. But the first two ones are important. The first one, it's about enabling the WIM automatic selection and configuration. So in order that OSM can configure and make use of one infrastructure managers for configuring the transport network between a number of sites in multi-site services that needs to be deployed. The second one is about a new one infrastructure manager connector based on ONF transport API. So the idea is that with this new feature, when you need to configure some transport network, you can do it quickly and without going into the details. You can use just abstractions of the network. And well, these are mainly features that we had to address at some point in order to bridge the gap between TeraFlow and OSM. Regarding the experimental demonstrations, well, we presented at OFC last year an initial integration between OSM and TeraFlowSDN. Here we were mainly establishing a new layer 3 VPN service. Well, I will not go into the details, but it's just to explain that we did this integration. And then at ECOC 22, what we did is an evolution of this experiment where we addressed how to establish redundant paths between a couple of data centers in order to provide high availability in the connection. So that way, we provide some form of SLAs for the connectivity service between the sites. Then, the long-term testbed architecture. That's, I will say, the meat of the presentation. The point is that many times discussing with OSM community, we are asked, yes, this is very nice what you are doing at TeraFlow. It fills a gap that we have, that is this part of the transport network in between multiple sites. But, well, the problem is how we address that. How we can do something that we can deploy, for instance, at ETSI premises, and then have an environment that we can use for testing both OSM and TFS. Well, let's try to bring some light here with a proposal. We can try to use network emulation. There are many network emulators nowadays. Here I'm just showing two of them, enumerating two of them. But here you have a link, if you download the slides, where somebody collected a huge list of network emulators. We choose a Container Lab because we think it's a very nice alternative. And I will go quickly. I will not spend a lot of time, but introducing what is Container Lab. The idea is that with Container Lab, you can deploy a set of Docker containers, each of them running the control plane and an emulated data plane for a network device. And then Container Lab also brings the capacity of establishing or creating virtual wires between these containers. So at the end, you can create a network topology. And the good point is that you can also expose some of the ports through physical ports in the machine where you are running Container Lab. So at the end, you can create a machine with a number of physical ports that are connected to the virtual environment of Container Lab. And inside Container Lab, you can deploy a number of network devices. The good point, you can configure them. So at the end, you can emulate somehow a transport network. It's not necessary to be just a transport. It can be also an intra-data center network, maybe. So that could be another option. Then, if we do that, what we can do is to create topologies, for instance, like these ones. This is just some example topologies, but the good point is that you can define the topology, the arbitrary topology you want. Then you can have, for instance, deploy some clients connected to this topology, besides connecting them directly to the physical ports. And that means you can do some tests. How you do that? Quick example, extracted from the Container Lab Quick Start guide. I will not describe everything. I only want to show you that with a YAML-based topology descriptor, like this one, you see we are defining one node, another node, and the link connecting these two nodes. You create the topology, and it has also in parallel a management network. With this, then, you need to have for sure the images for the different network devices you want to use. You run this command here, the Container Lab deploy, providing as parameter the file, and after a few seconds, you get your devices up and running. In this simple example, it's just a couple of devices, but as I said, you can have also a container running, for instance, a Linux box, where you can connect and throw commands, whatever. You get here for all the addresses you might need for managing the devices and so on. And the other good point is that you can get access also to the CLI, or the bash interpreter, if any, inside this network device box. That enables us to issue configurations if needed, or activate, for instance, other control protocols like GNMI, netconf, with data models like OpenConfig and so on. And well, destroying the box is also quite simple, just a command, and that's it. So at the end, this enables us to create this architecture I was mentioning before. We can have, for instance, a couple of OpenStack-based data centers, as I was mentioning, that can be under the control of OSM. Below, we can have TeraFlowSDN in charge of controlling the different network devices that are running inside Container Lab, and then we can connect the three blocks by means of this physical port that will be here on the border of this Container Lab box. And at the end, with this, at least we can have a basic environment for testing. The plans, well, before reaching this point, at TeraFlow, we need to address still many points, many open issues, in particular regarding automation of tests, integrating also some black box tests in order to ensure that all the software that we deploy is stable enough. We have part of this test, but we think it's important to increase this. Right now, we are running the CI/CD pipeline outside the ETSI Hive. The plan is to migrate this after the summer break. And then the next point is to automate the deployment of these Container Lab environments with TeraFlow. Right now, we are doing it by hand. And after that, we can start with this long-term testbed activity that we were discussing. And well, that's all, more or less. I don't know if there is any question. This one, you mean? This one is not already done. What we are preparing for next week Hackfest is a subset of this that is essentially the block under this this line. So this TeraFlow plus some devices. So right now it's kind of a proof of concept. We will see. Maybe we will identify that container lab, even when it seems to be a convenient solution. Maybe it's not, and we will have to switch to another one. We still don't know. So we are exploring in reality. Sorry? Yes. I mean, I'm writing here OpenStack, just to choose one of them for the sake of the example, but for sure, it can be whatever we need. Yes. Any other question? Yes? Yes. Right now, the one that we selected for this Hackfest is Nokia SR Linux because, well, it was convenient. It has support for OpenConfig and GNMI, and, well, it fits well with what we plan to do. But it has support for many others. So there are, for instance, network operating systems from Cisco, I remember, from Juniper, from Arista. I remember also the OCNOS from IPM Fusion. What else? Well, there is in Container Lab website, there is a huge list with many of them. The good point, I hadn't said that, but the good point of Container Lab is that it provides a lot of examples, quite elaborated documentation, and you have a lot of images that are available to download for free. So we think it's a good opportunity if you want to play with that, to do it for free, let's say. Any other question? Well, if not, I guess I'm done. Thank you very much.